3.
Assalamualaikum dan selamat sejahtera everyone. My name is Sanis Alisha and I'll be presenting the introduction for our group. Our project is titled Comprehensive Analysis of Classical Sorting Algorithm, Merge Sort, Quick Sort, Intersection Sort, Selection Sort and Bubble Sort. My member group are Ko Hong Rui, Teh Hiwan Chung, Muhammad Hanif, Muhammad Zaim, Kuhan and Ahmad Fahim. Sorting is a fundamental concept in computer science that help organize data and improve processing efficiency. The performance and sorting algorithm can vary depending on the input condition. In this project, we analyze merge sort, quick sort, insertion sort, and selection sort and bubble sort, choosing a random sorted and a reverse sorted data set to compare their performance. Through this study, we aim to understand how different input conditions affect the efficiency and behavior for each sorting algorithm. So next, I will pass to Muhammad Zaim.
Okay, these are the objectives. The first objective is to evaluate the performance of these sorting algorithms by measuring execution time and memory usage under varying dataset sizes ranging from 1,000, 5,000, 10,000, 25,000, 50,000, 75,000, and 100,000 elements. We aim to stress test the scalability of these algorithms by measuring both execution time and memory usage across dataset sizes ranging from 1,000 to 100,000 elements to pinpoint exactly where efficiency begins to degrade. The second objective is to analyze the impact of varying input conditions on algorithmic performance by conducting 10 experiments, 10 experimental trials across randomized, sorted, and reverse sorted datasets. To assess the robustness, we will conduct these 10 distinct experimental trials across these sets, ensuring we eliminate outliers and capture accurate performance data for both best case and worst case scenarios. The third objective is to determine the statistical significance of performance differences across algorithms and input sizes using analysis of variance ANOVA. We will validate our results using analysis of ANOVA, analysis of variance called ANOVA, to mathematically prove that the performance differences we observed are statistically significant and not simply due to random chance. Next, methodology.
So for the methodology, we use bubble sort. Bubble sort is a brute force algorithm which repeatedly compares adjacent elements and swap them if they're in wrong order. This algorithm is easy to apply, but it is inefficient when it comes to large data set due to its quality time complexity. For selection sort, it divides the list into sorted and unsorted sections and repeatedly scans the unsorted part to find the minimum element and swap it into the correct position. This method minimizes the total number of swaps but still requires scanning the entire list for every element. Insertion sort builds the final sorted array one item at a time by taking the current element and inserting it into its correct spot among the previously sorted items. It performed exceptionally well, but on small or nearly sorted datasets, because it minimizes comparisons. Merge sort is a divide and conquer algorithm that recursively splits the array into two equal halves, sorts them independently, and merges the result. It requires an auxiliary array for merging purposes. Quicksort efficiently partitions the array around a chosen pivot element, moving smaller items to the left and larger items to the right. But it is fastest algorithm on average. It can degrade to slow performance if pivot selection is poor on sorted data.
Now in this section, I will talk about the methodology used for evaluation the sorting algorithm. First, the data set was designed to assess a Scalability. We use the cross 7 different array size: 1,000, 5,000, 10,000, 25,000, 15,000, 75,000, and 100,000 element. We use 3 input variation: a random data where element are arranged in no specific order. The second is sorting data where element are already arranged in ascending order. And the last is reverse sorting data where the data is arranged is descending order. This represent the worst case scenario for many comparison based sorting. On performance metric, performance was evaluated using a two primary metrics. First, execution execution time, a measure in second, and second, a memory using, a measure in kilobyte. To ensure the consistency, each experiment was repeated 10 times for every input, setting across the all 5 the sorting algorithm. Now we will go to the performance comparison.
Now I will present the performance comparison. And we see the first left-hand side graph execution time with random data. And we can see the worst performance sorting algorithm in random data is bubble sort, the purple line one. The bigger input size resulting the more higher execution time. The best performance sorting algorithm in random data is quicksort, the dark green one, dark green line one, and have the lower execution time than all of other algorithms. Now we move to graph in the middle execution. In the middle, execution time with sorted data. You can see the worst performance sorting algorithm is in sorting data is selection sort, the blue color line one, and all the other algorithm in graph seem all have the minimal execution time. So we see the data table, and the bubble sort has the lower execution time. Now we move to the last graph execution with reverse data. We see the worst performance sorting algorithm in reverse data is selection sort in input size 100,000, but in size 75,000, bubble sort it have higher execution time than selection sort. The best performance algorithm in reverse data is quicksort again, but merge sort is slightly more than quicksort only. And we move to the next slide. And we can go to the memory usage performance comparison. First, we see the left-hand side graph memory usage with random data. The worst performance algorithm is merge sort, the orange color line one, and the best performance is blue bubble sort algorithm in size 100,000, the purple color line. And now we move to the graph in middle memory usage with sorted data. The worst sorting algorithm in merge is merge sort, the orange color one, and the best memory usage sorting algorithm in sorted data is selection sort, the blue color one. Finally, we see the graph memory usage with reverse data. The worst memory usage performance is merge sort, the orange color line one, and the best performance usage is bubble sort again. The other is slightly different to the bubble sort only. Now I will pass to my member, Cole.
Okay. For interpret statistical to scientifically validate our performance metric, we conducted a one-way analysis of variant ANOVA with a sample size of 100,000 across 3 distinct input conditions. They are random, sorted, and reverse sorted database. As you can see from the separate analysis database analysis table, the p-value in every scenario are significantly lower than the standard 0.05 threshold. So this statistical consistency confirms that the performance gap we observe are real and not due to system noise, proving that algorithm efficiency is the decisive factor regardless of how the input data is arranged. Next, I pass to Fahim.
So for the conclusion, there are 3 takeaways that I want to highlight. First is that sorting performance varies with input conditions. algorithm behavior changes significantly based on dataset size and whether the data is random, sorted, or reverse sorted. And the second takeaway is merge sort and quick sort are the most efficient for large inputs. Merge sort offers stable performance across all data types, while quick sort is fastest on random data but less efficient on sorted and reverse sorted inputs. And the third one is time efficiency is more important than memory usage. Although merge sort uses more memory, its fast and consistent execution makes it suitable for real large-scale applications. And so, all in all, this comprehensive analysis demonstrates that effective algorithm selection requires understanding not just theoretical complexity, but also the specific characteristics of your data and constraints of your system. So, meaning there is no universal best algorithm, only the best algorithm for your particular context. And so, that is all from us. Thank you for your attention.
Thank you.
11 minit cukup dah.